In the first video of this series, I looked at Al Gore's suggestion that this graph, which comes from the Vostok ice core, shows carbon dioxide and temperature in lockstep over the last 400,000 years. Just to recap, I'll let the film The Great Global Warming Swindle counter that one.
So here we're looking at the ice core record from Vostok, and in the red we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag, so temperature is leading CO2 by 800 years.
There have now been several major ice core surveys. Every one of them shows the same thing. The temperature rises or falls, and then, after a few hundred years, carbon dioxide follows.
So obviously, carbon dioxide is not the cause of that warming. In fact, we can say that the warming produced the increase in carbon dioxide.
And that's absolutely right. Researchers say carbon dioxide was not the cause of the initial warming during any of the recent deglaciations. The most likely trigger was the Milankovitch cycles, changes in the Earth's tilt and orbit that caused more insolation. In climatology, something that triggers higher temperatures is called a forcing, so greater insolation due to the Earth's orbit is called orbital forcing or insolation forcing. The problem is this explanation has given rise to yet another myth that I'm going to deal with in this video. But first, a quick recap of myth number one.
CO2 clearly cannot be causing temperature changes. It's a product of temperature. It's following temperature changes.
Now, just because an increase in temperature puts more carbon dioxide into the atmosphere, which is true, that doesn't preclude carbon dioxide also causing temperatures to rise. Similarly, just because insolation causes temperature rises, that doesn't mean carbon dioxide can't cause temperatures to rise. Otherwise, you could say that because kinetic energy can produce heat, then it must mean that heat can't produce kinetic energy. So let's go back to that graph which Durkin attributes to Caillon et al. He's probably referring to this famous 2003 paper in the journal Science, which is where that 800-year lag comes from. By the way, Caillon says there's a margin of error of 200 years. Caillon was looking at the end of one of several glaciations during the Ice Age, this one called Termination 3. It marks the end of a glaciation about 240,000 years ago. Durkin's correct in saying there's an 800-year lag, but he didn't tell his audience what was in the rest of Caillon's paper. The data for the graph, here's the real one by Caillon et al., comes from an ice core at the Vostok station in Antarctica. Since the 1980s, ice cores have been getting progressively deeper, and the 800-year lag everyone now talks about comes from a core that was first analysed in 1999. So Vostok doesn't record global temperatures, it records Antarctic temperatures. And although temperature did indeed lead CO2 in Antarctica, Caillon concluded that temperature rises lagged CO2 in the northern hemisphere, and he said so in his paper. A more recent paper by Shakun et al. Shows how much temperature leads CO2 in the southern hemisphere and how much it lags in the northern hemisphere. The rise of CO2 level and the warming effect that produces is not only consistent with observation, it also explains something that's otherwise inexplicable. A paper by Lorius et al. Shows that insolation has varied by only 0.7 watts per square metre over the last 160,000 years. In other words, the tiny amount of forcing due to the Earth's orbit wasn't enough to defrost miles of thick ice covering a large part of the planet. It was the amplification of this initial warming by other factors, mostly greenhouse gases, that gives us the complete picture, which goes like this. The initial warming at the end of each glaciation was probably caused by orbital forcing. Carbon dioxide in the atmosphere played little or no part in this initial warming, and because CO2 is more soluble in colder water, a lot of it was dissolved in the deep oceans. But the higher temperatures caused by orbital forcing led to stronger winds and warmer water. Over several hundred years, that caused CO2 to circulate up from the ocean depths and eventually degas at the surface. As CO2 levels in the atmosphere rose, over the next few thousand years the greenhouse effect gradually took over from orbital forcing to become the predominant cause of warming. This amplification of the initial warming is a process known as positive feedback, which I explained in the first video of this series. Then as the Earth continues its wobble and erratic orbit, less insulation begins to fall, and that triggers lower temperatures, causes more atmospheric CO2 to dissolve in the oceans, and the process goes into reverse. We get another glaciation. So Lorius's and Shakun's conclusion was the same as the conclusion of Caillon and every other researcher in this field, that carbon dioxide both lags and leads temperature rises. Caillon explains all of this in his paper, but that wasn't mentioned in the great global warming swindle. Neither Caillon nor Severinghaus nor Jouzel or any of the authors of the paper Durkin cited were interviewed for the film. Instead, Durkin got a geochemist with no publishing history in this field to voice his beliefs. If Ian Clark has some reason for believing that CO2 can't lead as well as lag, he doesn't tell us what it is, neither does he publish a paper showing his evidence. Of course, it's possible that real climate researchers are all corrupt and hurriedly made up this nonsense in order to explain the embarrassing fact of the time lag, because it threatened to scupper their hoax. Here's what civil engineer Frank Lanzner wrote about the 800-year lag on What's Up With That. This is the climate debate, so massive rescue missions have been launched to save the CO2 hypothesis. So explanation for the unfortunate CO2 data is as follows. First, a solar or orbital change induces some minor warming, cooling, and then CO2 raises or drops. After this, it's the CO2 that drives the temperature up or down. Well, that's more or less the theory in a nutshell. But if Lanzner thinks this explanation was hurriedly cobbled together to explain away an unfortunate lag, he obviously hasn't looked at any of the scientific papers from decades past. I've done a trawl through the scientific literature, and there was no question that since at least the 1980s, researchers had been expecting carbon dioxide to lag the initial temperature rise. The only question at the time was, how big would the lag be? Neftel et al. In 1988 thought CO2 probably lagged by less than 1,200 years. A 1990 paper by Lorius et al. Predicted a lag of between a decade and over 100 years. A paper by Barnola et al. Estimated the lag time at less than 1,000 years. So why were they all so sure that CO2 lagged the initial temperature rise? Because there had never been any question of it not doing that. I couldn't find any papers suggesting that carbon dioxide led temperature rise at the end of each glaciation. Here's a paper going back half a century, explaining how orbital forcing was the likely cause, and by the 1970s that explanation was widely accepted. And by the 1970s, positive feedback was also well understood. Here's a Nature paper from 1972. It was talking about warming predicted because of a 20th century rise in carbon dioxide, but the same principle applies whatever the cause of warming. A rise in temperature of the oceans will itself release additional carbon dioxide to the atmosphere and provide a positive feedback, tending to enhance slightly the carbon dioxide effect. This paper by Satltzman also describes how carbon dioxide released from a warming ocean amplifies initial warming. Just as Lorius and Barnola had predicted, and other researchers have confirmed, it was positive feedback that defrosted the planet, not orbital forcing. But this myth that the unexpected discovery of a lag has turned climate theory on its head has persisted simply because it's been copied and pasted again and again for the internet version of the scientific literature, the blogosphere. Even this year, when the Niels Bohr Institute in Denmark published yet another paper on what's become the standard model of deglaciation, this time calculating the time lag at much less than 800 years, the bloggers still saw it as confirmation that CO2 always lags temperature and therefore cannot lead. Introducing the study on What's Up With That, Anthony Watts wrote, "The question of which comes first, the temperature or the CO2 rise, has been much like the proverbial which came first, the chicken or the egg question. This seems to settle it. Temperature came first, followed by an increase in CO2 outgassing from the ocean surrounding Antarctica." Well, welcome to a conclusion that was first reached 40 years ago. Sorry, but this isn't like the chicken or the egg question. Researchers have known for decades which came first. I know I'm repeating myself, but just how hard is it to check these past papers? Even the news release accompanying the study and reprinted right below Watts's statement belied the chicken or the egg metaphor and confirmed exactly what I've been saying. It had previously been thought that as the temperature began to rise at the end of the Ice Age, an increase in the amount of CO2 in the atmosphere followed with a delay of up to 1,000 years. And further down, also reprinted on What's Up With That, the same news release said this: the global temperature changed naturally because of the changing solar radiation caused by variations in the Earth's orbit around the Sun, the Earth's tilt, and the orientation of the Earth's axis. The natural warming of the climate was intensified by the increased amount of CO2 in the atmosphere. Sound familiar? Misunderstanding of the CO2 lag is a pretty persistent myth, and it crops up all the time. It's not an easy one to understand because it's part fact and part fallacy, so you have to unravel what's actually in the scientific literature and what isn't. So let's sum all this up with a quick quiz.
Published papers clearly shows that it is always the temperature rises first by at least several hundred years to a few thousand years, and then the carbon dioxide curve responds.
True, if we're talking about the initial cause of deglaciations and Antarctic temperatures rather than global temperatures. Willie soon doesn't make that clear, but let's give him a point anyway. And since researchers predicted this lag over 20 years ago, then of course they deserve a point too.
Temperatures go up, then CO2 concentrations go up. CO2 does not drive temperature.
Result, carbon dioxide may in fact follow the temperature change as opposed to being a leading indicator.
False, if the only argument here is that something can't be both a cause and a product of that cause, because nature proves that wrong time and time again. The Amazon rainforest is a good example. More vegetation promotes evapotranspiration and encourages rainfall. More rainfall leads to more vegetation. More vegetation promotes evapotranspiration, and so on.
They said, if the CO2 increases in the atmosphere as a greenhouse gas, then the temperature will go up. But the ice core record shows exactly the opposite. So the fundamental assumption, the most fundamental assumption of the whole theory of climate change due to humans is shown to be wrong.
False. The most fundamental assumption for decades was that temperatures would rise first because of orbital forcing, then carbon dioxide would rise, then that carbon dioxide would cause further warming and the release of more greenhouse gases until the temperature stabilized at a much higher level. These assumptions, if Ball wants to call them that, turned out to be correct.
At the end of that round, the scores are...
So either the critics don't know the whole story, or they're deliberately ignoring it. I don't know which it is, and as always I'm not going to ascribe motivation. All I can do is show what's in the scientific literature and cite the sources so that you can check it.